All right, let's get started. I'm recording this short tutorial for a web-based app that we recently developed. It's called NeuroCurve. It's a Peter transfer function for estimating soil hydraulic properties. To access the app, you can come to ucrwater.com and go to apps, and then you can see all the apps that we developed here. The latest version should be here. This NeuroCurve, the current version is here. You click on it. If someone has been using the app recently, it's just gonna pop open immediately. Otherwise, there will be a message that the app is sleeping or something like that. Then you click, and then it takes a few minutes for app to load. We have a paper in review for NeuroCurve that will have lots of information about the tool, the fundamentals of the approach that it uses, that is pseudo-continuous pseudo transfer function. Is not listed here because it's under review. As soon as it's published, I'm going to add it here. But you have a bunch of other papers are cited here that you can access them all through my website. Originally, the idea of pseudo-continuous pseudo transfer function was introduced by me and a few colleagues in 2012. And if you're a pseudo transfer function user, you probably know how it works. It's just a different way to arrange and to change the topology of neural networks to be able to get continuous estimations of water retention and later on hydraulic conductivity using neural networks. So then we have all other papers. This tool is trained using high-prob data. The first paper that we published on pseudo-continuous neural networks and high-prob is this one, 2018, in Journal of Hydrology, so you can actually read this. And later on, my former PhD student, did a paper in which we look at how this approach works. So let's get into it. NeuroCurve, there are some information that you can actually look at them here. It's actually pretty easy. The only thing that might give you an error is that if you label the data that you have incorrectly. There is an optional first step, or step 0, if you will, to clean your data. And by cleaning, meaning that remove the repetition in your measured hydraulic conductivity or water retention data. I already did that, so I'm not going to use this. But if you upload the data, I think NeuroCurve is going to give you an error if there are multiple measurements with the same PF value for each soil type. Other than that, if you have a clean data set, I'm going to run a few tests here. This tool is super fast, so you'll see it. The data set that I'm going to use is an international data set. So for regional data sets and local data sets, it should be even faster. First, let's just assume a scenario in which we don't have measured data. We just have basic soil properties, which is the main premise of pseudo transfer functions, right? So you measure soil texture and bulk density and organic carbon content, or at least soil texture, and then the tool gives you hydraulic conductivity and water retention curves. So I uploaded my file. Before going any further, I'm going to show you how the data are formatted. I forgot to do that, so it's best to do it right now. You should format your data as CSV file. So this is the input. Has a column for soil number, clay, silt, and sand percentages. You add them, should be 100%. Bulk density and organic carbon content. These labelings are important. So if you don't add these parentheses, for example, for bulk density, you may get an error. So just if you're watching this, pause and create a CSV file just like this. Each row is a separate soil. Soil number 1, soil number 2, different combination of inputs. At least you should have soil texture. So if you have soil texture, don't have bulk density or organic carbon content, you should still be able to use the tool. If you're a high-prob user, which is this tool is mainly meant to be used by high-prob users, then you have hydraulic properties measured too. So you can get them directly from high-prob generate data. So you run your high-prob. This is for graduate student. You know this already. Do high-prob fit, select the model, export the data, and then there should be 2 sheets in your files. One has measured water retention and one has measured hydraulic conductivity data. Those you can just use them, put them in a new file, CSV file, change the labels, and then you will have a file like this. For each sample that you have, if you decided to upload measured data, for each sample that you have in your basic soil properties CSV file, you should have measured data too. So this is soil number 1, for example. You see that we have 10 measured points. PF is the natural log of soil tension in centimeter of water, and then theta is volumetric water content, right? So this is for volumetric water content and water retention curve. Same file for hydraulic conductivity curve, which is, again, it's going to, HyProb is going to give this to you. If you have WP4C added to your HyProb, when you use HyProb fit, you add it to that, and then it's going to be actually populated here automatically. If you have KSAT, that's going to give you saturation water content. To add that too, that's going to be here. Then tool can look at that as well. So this is, again, should be log transformation of K, PF, log of soil tension, and soil numbers. So back to the file. First, assume that you don't have any measured data. So just upload your inputs. You can preview your data, what you have, and then come here to select your model. So there are different combination of inputs depending on what you provided. Here we have all 4 models that the tool has: soil texture, texture plus bulk density plus organic carbon content, bulk density, and organic carbon content. So I'm going to just select soil texture and bulk density, or maybe plus organic carbon content. Number of ensemble models. So this is a neural network. If you choose 1, it's going to just pick 1 neural network. If you choose more than that, 46, it's going to run 46 neural networks and then average them. All right. So let's run this quickly, see how long it takes for the tool to generate the data with 46 neural network models. So you see that it's pretty fast. Then you have the prediction results. You don't have performance metrics because there was no measured data provided. And these are the curves. So at least you get these: water retention curve and hydraulic conductivity curve. And that bound is uncertainty bound, this plus minus of the standard deviation, because we did ensembling or bootstrapping. Next, let's just do a fitting as well. So you can fit a hydraulic model, because although pseudo-continuous speed transfer function is very strong, lots of studies show that, but one shortcoming has been so far that you run this type of speed transfer function, then you cannot, it gives you only estimated curves. It doesn't give you coefficient of hydraulic conductivity models that you use. You should have them, for example, to run, let's say, hydras. This model, this tool, one of the novelties that it has a post-fitting module. So you can either fit Wangen-Ochten or PDI variant of Wangen-Ochten. So fit, are you going to fit it to measured data or PTF data? Here we don't have a measured data for, that's the scenario that you're running. So I'm going to fit PDI model to my neural network output. So what it does, neural network is going to estimate the water retention and hydraulic conductivity curves, and then tool is going to grab those and fit PDI, and then you can just plug those coefficient and play with whatever tool you want to use. So you can see it's pretty quick. Standard prediction table, fitted hydraulic parameters, all the parameters that you need to use to run your PDI model, performance, how well is fitted versus neural network. And you can see that in the visualization, now we have fitted as well. And you see fit is really good. Let me actually switch to randomly another. So did a pretty good job. And you can download all the data as CSV file, all the results. Now, if you, again, you're a HyProb user, you probably want to test this tool for your soils samples. Then you have measured data. You can upload measured data. Even without measured data, you can change the PF grid. The embedded PF grid goes from 0.3, so saturation, to 6.8 oven dryness. But most of the time, people have predefined PF values, so you can create a separate CSV file and upload it. There should be 2 columns at least. Soil number and then PF values for each soil. Otherwise, tool is just gonna use the embedded PF grid. Now I'm gonna upload the measured data, volumetric water content, and the hydraulic conductivity, and just gonna run the same, just run the same tool again, post-fitting everything, and see what happens if you have measured data. This is an international data set, so a couple of thousand measured data points. You can see the tool is very fast and responsive. So for regional and local data sets, it will be even faster than this. Again, you have the fitted values. The only thing is that here now the performance table has more values. Measured versus P2 transfer function. You can see that they work pretty good. R square are good, README squares are good. And now you have measured data. This is the entire data set, scatter plots, and then for each soil sample, you can actually look at how model worked. So for some samples work really good, for some others maybe not. So that's pretty much it. We have another tool. If you haven't checked that tool, you can check that as well. And there is another tutorial for that. It's called Curve with K, that uses a lazy learning algorithm, K nearest neighbor, but the outputs are similar and the structure of the app is pretty similar to NeuroCurve. If you found any bug in the tool, please just email it to me. If you're interested in collaborating with me on this international evaluation of these tools and you have high prob data sets, let me know. I'll be happy to talk to you about that.